All right, so this is going to be just going through a example circuit of two series circuits that are in parallel with each other. So I'm going to make my VIR table over here, R1, R2, R3, R4, and then I just the equivalent or the total on the bottom there. Putting some lines. Okay, so I can get my resistor values straight off of the resistors. So 600, 100, 700, 100. And then my total resistance I got to calculate. That's going to be a little bit of math to do because it's not as simple as a singular process of series or parallel. My total voltage, my overall voltage here though, is 12 because I'm reading it off the battery. So with any of the combination circuits, one thing that does help me is I'll redraw sort of an equivalent system. So if I draw like a 12 volt battery down here, pretending this is just kind of like a simplified version of this circuit. So these two resistors functionally are equal to a resistor that's 700 because this branch is providing 700 ohms of resistance. This branch is 800 ohms because it's these two added. Because they're in series, we're going to treat them like a series circuit would in the math. So those are just adding them like that. Now that I've got this kind of simplified version, I can do this the way that I would do a a parallel circuit. So now I can go in and write out, this is going to be, the way I would solve the overall resistance of that would be 1 over 700 plus 1 over 800. So that is what I'll do to get the total resistance. Alright, so once I did that, in the end I got 373.3 repeating indefinitely. Now with these circuits, I always double check myself in a parallel circuit. The total resistance is always less than the lowest branch. So the lowest branch in this simplified circuit is 700, so that's less than 700. So I will say that that is within the realm of possibility. So the total resistance of the circuit is 373.3. One thing I was telling my students the other day is it's got to be, if you're looking at this, it's got to be less than the lowest sum of a series strand. So like this series strand is 700, this series strand is 800. So therefore the total resistance of the circuit has to be less than a single strand's total. So that's my resistance. Now to get this, going across Ohm's law is always going to be going on. So going across V equals IR for this row, for the totals row, that's going to be 12 equals I, which I don't know, times R, which I just found out, 373.3. So if I do 12 divided by 373.3, hit enter, because I'll divide both sides by that to cancel that out. So in the end, my current equals 0.032. 0.032. So I have 0.032 amps of current going through the circuit based on the way it's set up. So as it's going through the circuit, it's going to come through and it is going to split up. Some's going to go down this branch to this parallel, and some's going to go down this way to this parallel. I don't know how much is going to each branch, but I do know whatever goes down this branch is going through R1 and R2, and whatever's going through this branch is going through R3 and R4. So there's a bunch of things we kind of got to work around to get to the point that I can figure out what is the current and voltage at each resistor, because those are still missing off my table. So looking at my simplified version, we can do this off the simplified version and then kind of backtrack. So this strand is providing 700 ohms of resistance. The voltage across that strand is 12 volts because it's in parallel with the battery. So for this strand, V equals IR needs to apply, and for this strand, V equals IR needs to apply. So what that's going to look like is the current going through this strand whether it's 2 resistors or this simplified version showing them as kind of an equivalent resistance, is going to be 12. We don't know the current, but we know the resistance of the strand is 700. And then down here, it would be 12 equals current times 800. So 12 divided by 700, 12 divided by 800 to solve for I, solve for current. 12 divided by 700. I'm using a calculator that's putting in as fractions, so I have to do extra steps. Show me as a convert to dozen. 0.017. So the current 0.017 going down this branch, and then this 12 divided by 800. Show me as a decimal. Is 0.015. So I equals 0.015. Now, because they're in series, everything in the branch is going to have the same current. So 0.017 is going to be the current going through R1 and R2, and 0.015 is going to be the current going through R3 and R4. Because if it's going to go through R3, it's going to go through R4. They're on the same path, so the flow is going to go through them both. Now, the check for me on this, whoopsies, I missed a 1. If these, so this is 0.017 for these two, this is 0.015 for these two, if that plus that equals that, or fairly close because there is some variance with rounding, you're good. Like, you're most likely going to be correct. These checks, in order for you to be wrong and still have the checks work out, is very difficult from what I've seen with my students. So I'll just say, okay, does your series 1 plus series 2 currents equal the total current? If so, you're probably in a good place. Now to find voltage, we're going to do Ohm's law going across for each of those. So I'm going to do voltage is current times resistance, and I'm just going to go through and do those all. My check with this, I know there's 12 volts across this branch, and there's 12 volts across this branch. So if my voltage at R1 and R2 adds up to 12, and then separately my voltage of R3 and R4 adds up to 12, I should be correct. So let me just crunch the numbers, I'll put those in, and I'll show you that check. So with the numbers in place, I multiplied across to get this voltage column. So I had these, and I just multiplied across. Whoops, focus please, thank you. This plus this, it's about 12. And this plus this, it's about 12. There's sometimes a little bit of rounding difference, but as long as it's not a lot, so it's only off by like 0.1, I think. This is 11.9. This is 12 on the dot. We're in a good spot, I think, that's my check for voltage. So this is the kind of solved out current, resistance, and voltages at each of the resistor locations. And this is a setup where we have 2 series circuits that are in parallel to each other. This is my example. Let me know if you have any questions. Thank you.